Testing Frameworks with Andrew Locke.
The Azure and DevOps podcast is a show for developers and DevOps professionals shipping software using the latest in .NET, Azure, AI, and DevOps. Listen on to learn how to increase quality, ship quickly, and operate well. The show is sponsored by ClearMeasure, a full-service software architecture and engineering firm. Find them at www.clearmeasure.com. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your team move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. Quick announcement, I am hiring a software engineer at ClearMeasure. Just go to the website and find more information about it. And it'd be great to work with you. So let's get into our guest. Andrew Locke is the guest on our show today. He is a staff software engineer at Datadog. And he's also an educator whose contributions to the .NET ecosystem have really shaped how developers approach modern web development. He's located in the UK, and he is a Microsoft MVP. He's also the author of a book, ASP.NET Core in Action, and he also has a very active blog that's all about his experience working with .NET and ASP.NET Core and all things C# and .NET. You can find that on andrewlocke.net. So, Andrew, welcome back to the show. How are you, sir?
Thank you very much. Yeah, it's good to be here. I'm good, thank you. How are you doing?
Great. And you were last on the show on episode 281, where we were talking about web applications, and we'll include a link to that in the show notes. But for people who didn't catch that episode, before we kind of get into testing frameworks, you've been a programmer for quite a while now, and I'd just like to kind of ask an opening question. What is it about programming that keeps it fun, where you think, you know what, I'm going to keep doing this, as opposed to, some programmers, move into different areas. But what is that trigger where it kind of still has a grip on you?
Yeah, I think there's a few things I like. One of them is just learning new things. I enjoy that. I enjoy exploring how things are changing and what we can do with that. The other thing is it's the actual joy of coding. I enjoy problem solving. I quite like the sort of working in the minutiae, figuring out the correct way to do things, which isn't always what you need to do in your day job. But on the side, I do like agonizing over the different sort of the minutiae of coding. I enjoy all of that sort of stuff.
Yeah. I started programming in 1997, and just the materials. I love the materials where it's not like wood or metal. We're not constrained to physics. If we need more space in a software system, we can just get more space. We can just keep on growing.
Yeah, it's true.
It's fun. Well, you, your blog is prolific at andrewlocke.net. I mean, just any listeners out there who have not seen your website, we'll include a link to that in the show notes. But you've got so many good things out there, and one of the recent ones that really caught my eye and realized, oh shoot, how long has it been since I've had you on the show? I need to get you back on. You wrote a blog post where you were kind of comparing this new testing framework called TUnit with XUnit, and you compared it with MS Test and InUnit, and you were just thinking about testing frameworks, and I realized, you know what? It's been a long time since there's been an industry discussion on testing frameworks. But as you were looking through that, I'd love to pick your brain and think and ask, what is your assessment? What testing frameworks are you using right now? Why TUnit kind of caught your attention, and what did you learn through your investigation?
Yeah, so like you say, there's a lot of different testing frameworks in general, and for .NET, I assume we're just considering .NET at this point, really.
Yeah. But is there anything else? Come on.
Yeah, I mean, there's a sort of classic MS Test, NUnit, XUnit. These are all testing libraries that have been around for years now. MS Test was the one that I think a lot of people always started with because it came from Microsoft. And so back in the day, it was the one you sort of used. But then NUnit was a sort of a reimagining of MS of what a testing framework could be, which introduced a lot of interesting new concepts or just neater ways of doing things, I think, with setting up and tearing down. I personally never really used NUnit that much. I always had ended up using XUnit, which sort of became almost the de facto default version used by a lot of open source frameworks. Even .NET, ASP.NET Core, when it was redesigned about 10 years ago now, they favored using XUnit. So I think a lot of people just default to XUnit. And in some ways, it's like, it doesn't really matter. Like these testing frameworks, they can all pretty much these days do the same thing. Those sort of XUnit and unit MS test. It comes a bit down to just taste, what you like, what you don't like. But for the majority of things, they're the same. At least that was true until recently. XUnit has gone through a major version change. So the XUnit v2 has been the version to use for a long time, basically since .NET Core came out. And they're now moving to a v3, which, as you'd expect with the major versions, it's got breaking changes. They're changing supported testing frameworks. They optionally allow running on top of a new component, which is being shipped by Microsoft, called the Microsoft Testing Platform, I think, which is a complete reimagining of how testing works in .NET, like at the core components. It doesn't matter for you as someone who writes tests, but for someone who's building a testing framework, it changes fundamentally how things work. So it changes how you integrate with Visual Studio, for example. It changes how you integrate with .NET Test. All of those bits have changed. But that transition from XUnit, going from v2 to v3, that's what really made me wonder, like, should I be using XUnit? If I need to do a major version update anyway, what else is out there? What else can I use? And that's when I noticed TUnit, which is this much newer testing library. Newer as in it's only, I think the first alpha was in 2024. Instead of 20 years of development, it's had literally a couple. Or
30 or 35, because NUnit was originally a port of JUnit from the 90s. And then, if developers have been developing after 2005, then none of that history is relevant because that's when MS Test came around and kind of built it into Visual Studio. But XUnit has kind of quite taken off ever since it was created, because I think James Newkirk was one of the original developers who was involved with the NUnit project and kind of took over. So what did you find as you dug in further?
Yeah, so I mean, the main thing I found with TUnit is it's very much designed to address some of the sort of edges that you can often run into with something like XUnit. I get the impression, in fact, he was essentially the developer who originally did TUnit, was using XUnit and got a bit frustrated by it, and so decided to create TUnit. And so there's a bunch of considerations in it which make it easy. Like you can there's no limits to running things in parallel. There's a whole bunch of various features in general. One of the most important is, well, I say most important, one of the considerations, which may or may not be important depending on how you feel, is it's fast. Like it's designed to run lots of tests in parallel to take advantage of your computer as much as possible. And it supports native AOT, so you can run tests. If you're building native AOT apps, it's important to run tests using native AOT to make sure that you are actually, the runtime behavior is what you expect it to be. And so those couple of features, for some people, will be very important. For others, it's just a nicety.
Now, you have a table on your blog about the speed of different benchmarks, and you said you ran it on your own computer. The numbers, how did you measure that? The numbers you publish are very different for TUnit. So what exactly was your measurement methodology to realize, like, oh wow, TUnit is way faster? Way faster at what? Yeah,
to clarify this, I didn't run these. These were run. I took these results from the TUnit. It's on their README. They describe
from the group itself. Okay.
Yeah, exactly. They describe the scenarios in there. But the main reason for the huge difference is parallelization. XUnit and others have more limited parallelization options, whereas TUnit goes out of its way to try and parallelize as much as possible. There's other small advantages that TUnit gets as well, because TUnit is all source generator based. So whereas all NUnit, XUnit, MS Test, they all do essentially the discovering of tests at runtime. So you just create either a console application essentially or a library, and then the XUnit framework looks through your assembly to find all of the things decorated with like factor theory to decide if they're tests, and then sets up everything there and works out what to do. Whereas TUnit does essentially all the same work, but it does all that at compile time. So that means when you come to actually run your tests, it's that much faster.
Got it. So the numbers there, what was it, 13,000 or 13 some odd thousand milliseconds versus a few hundred milliseconds, less than 1,000 milliseconds. Now, is that to run a single test? Is that a full spin up of the library?
That's spinning up tests that take. So that's where believe it was a test that lasts 50 milliseconds to run a test, but it's executing like 100 times. I think it was running 100 times and then initializing the test framework on top of that. It's essentially running, a slow test 100 times. Yeah. Difference is it does it all in parallel, basically.
I've got, software that has thousands of unit tests, and I guess because I'm older, I'm used to using NUnit, but XUnit to me it's like, I kind of use the same features. And testing frameworks have kind of become commoditized now, except for the runner, because you're going to have a test method. If you need to do some setup for the test, well, XUnit just likes to use a constructor because classes tend to have a run once method, and okay, that all makes sense. I've gone to libraries like shouldly or asserts. So I don't even use the asserts that are built into the test frameworks anyway. And really what I'm excited about is there a way to radically speed up the execution of big test suites?
Yeah, well, it depends. Like it depends what is taking the time, I think. If you are already essentially maxing your CPU out at trying to run these tests, then probably not. You could speed them up by doing less work, and so TUnit does moves all that work to compile time, which arguably is shifting when you're doing that work, but still doing it. If on the other hand you're not, if you're doing async tests, for example, if you are just sort of waiting at various points, maybe you're not actually hammering the CPU 100%. Maybe you're not using all of those threads you've got available to you because of the way that the context flows between different tests. Because XUnit basically limits the number of threads, if I remember correctly, but not the number of concurrent tests. So if all of your tests are async and all of them are doing a wait, and let's say you're doing network I/O, so you're just sat around waiting. For XUnit, that will basically be sat around waiting. For TUnit, it won't. You can have another test going in the background. That's fine. So in that situation, maybe it could significantly speed up. I think the only way to really know is to give it a try. Right.
And I'm guessing you haven't converted any big test suites to TUnit just to try.
I've converted one of my projects to TUnit. It's an open source library, and I wanted to try. So TUnit has a set of analyzers and helpers to automatically convert from XUnit to TUnit for you, and it works really smoothly. So I gave that a try. And I've got to say, it was faster. Like when I'm running the tests, it seemed to be faster. I don't know if that's I didn't measure it. I haven't measured the duration. So that's just anecdotal. But
anecdotal is valuable. Like, do you remember that it took a certain amount of time to run it before, and then after? Was it twice as fast? Like, if you stick your finger in the wind, what order of magnitude do you think it was?
Yeah, if I stick my finger in the air, I would say it was about twice as fast. But it wasn't a huge test suite. So, I mean, it took probably, I think it was like 10 seconds to run the whole suite. And so it was probably double that beforehand, potentially.
Right. Yeah, it's one thing to think about, what test what test framework to use, but just like when there's multiple IOC containers, there was multiple structure map, Lamar, and all, and then Microsoft said, why don't we create a set of abstractions? And now, okay, you can use any of them, but they all just flow into iService provider under the covers. I'm wondering if our test frameworks are getting to the point where it's like, what, we've kind of agreed that we're going to have test classes, and those are going to have methods that are test cases. And yeah, we need to depend on certain things. We need to have, setups per assembly. It's almost like the abstractions have, the dust has settled on what we believe are generally useful. And now it's all about, okay, these take time to run. Now we really need to make it faster. And whether or not T-Unit takes off or not, again, it's almost like the advances, the R&D, the advances. How long is it going to be before, somebody says, hey, let me submit a pull request to T-Unit, to N-Unit or X-Unit. Yeah, we can have a different run mode in here, and yeah, we can run it this way too.
Yeah, and to be fair, a lot of the features which are in T-Unit and which they highlight as differences between X-Unit, a lot of those are differences between X-Unit v2. And so X-Unit v3 actually brings a lot of the similar features. The main reason that I was concerned about moving to X-Unit v3 for my own work is that they have taken a much more conservative approach to backwards compatibility of testing, like being able to run against previous frameworks. Only .NET 8 is in support right now, .NET 8, .NET 9, and then .NET 10 coming. But for my work, and also for some of my open source, I need to run against very early. I need to test like .NET Core 2.1. I need to test .NET Core 3.1. Not because I want to, but because I have to. So,
sure. Oh, yeah.
And so that was one of the considerations I had, is that XUnit v3 doesn't support those. You can't use XUnit v3 with those early versions. Whereas TUnit, currently, they target net standard 2.0, so you can run against
it doesn't matter.
And there's no guarantees, but it works, so it's fine.
Right.
So that was one of the actual distinguishing feature which made me have a look at it as a potential candidate. Although the rest of it was nice too. That was the thing that was the main reason for me.
Yeah.
But actually conversing between the two was really smooth.
You mentioned parallelization in the CPU. It seems like the number of concurrent threads continues to go up, and like it's common now to have just regular computers having 24 cores, and which is 24 logical processors that are running, if they're true unit tests and they're not trying to call out to the database or file system or somewhere else, but staying in memory and like actual unit test, it seems like we should just run them all in parallel up to the point that the computer can actually handle architecturally, right?
Yeah, absolutely. It's interesting. I feel like everyone starts out with that as their goal for their unit test suite, and then slowly you get these various bits. You're like, oh, this one, I can't run these in parallel with those other ones, so I'm going to have to make sure that I run some tests which do some extra work after these other tests, and that's okay. Like that's reality. You have to do that at some point. But that's one of the things I think that TUnit does quite nicely, is you can actually codify that into the tests and saying like, I can't run these ones in parallel with these other tests, so make sure you do them separately, or they run them afterwards. You can have ordering tests, which is something else that means you can still have your split up nice units to test, but then have an overall flow that you want to test, for example. Which, whether that's a good idea or not, you can argue, but you've got the capabilities to do that with TUnit, which is, you can do in XUnit, because essentially everything in XUnit you can plug in and change and customize, but it's just built into TUnit, so it's that much easier to do.
What I wonder is as tests become pretty much, or automated tests, well, they have become the de facto manner of testing before we actually ask someone in product management to look at it with their own eyeballs. I'm wondering if there's multiple unit tests projects that are just yearning to come out. Like if there's a cluster of tests where, oh, wait a minute, for this set of tests, okay, we need to have some routine set up so that there's some hydrated shared things in memory. And yet you have the depends on attribute and T-unit. But if it would make more sense to us humans to actually have a second unit test library in our Visual Studio solution for that set of tests, whereas the rest of them that are nope, these are idempotent, they don't have any dependencies, they're clean. I don't know, just a thought.
Yeah, I think it's reasonable. I think it's actually similar to the approach that we take in my day job. We have a bunch of different test projects, one of which is basically, as you say, unit tests, and the unit tests are meant to be just like, you can go nuts, you can just run them all in parallel, it should be fine. We have integration tests, which are much more considered. Some can't run at the same time as others. You can generally run them serially because of the way they work and the fact that they're stateful. And you've got some others which are sort of in between, but just want to keep them separately. I think it's definitely an approach you can take. The main downside is that every time you add a new project, you're adding a bit more overhead in terms of just on Visual Studio. When I open up the solution, it's got 300 projects. Everything slows down.
Right.
And all of the matrices get more complex, and just generally everything's a bit slower. I think it's a trade-off. As with all these things, maybe it's easiest to keep them in the same project. Maybe it works out better overall than just to separate them using traits or some, similar. You've got to try and see.
Now, everybody in the industry is, trying to figure out what GitHub Copilot can do and generate some code and then tell it in Copilot instructions, okay, run the unit tests, because if what you just did causes the unit test to fail, then it doesn't matter. What level of exploration have you done as it pertains to AI-driven development and the intersection of actually running test suites?
Not a huge amount, in honesty. I've experimented a little bit. I've done a little bit with Copilot. I've done a little bit with Claude Code, and more so with Claude Code. And I find that it's pretty good as getting it to run the test suites, as long as you are able to essentially just go .NET test and have your test suite run. It's generally pretty good at doing it. It's generally pretty good at creating tests that exercise some of the functionality. I think you have to be a little bit careful with them generating tests, because sometimes there's the classic, oh, this test is failing, how do I fix this test? I'll delete the test. That's a classic thing which people have run into. So you got to be firm, and you got to make sure that actually it's doing what you want it to do. But in general, I think as all of these test frameworks essentially plug into the .NET test infrastructure, it's easy for the AIs to know how to run your tests. I think when it comes to generating the tests, something like T-Unit there's going to be less training data, basically. So I think it would be most likely harder to be generating tests with these newer frameworks. That'll alleviate over time, but otherwise you're stuck with
Yeah. And with so many new developers coming into the industry, that they're being told, oh, you need to write automated tests. And there was a period of time I think it was right around 2005, and early .NET 1, 1.1, and 2. Well, right before .NET 2, anybody who was doing automated tests with .NET was using InUnit. And there was this industry discussion on classifications of tests, and then Visual Studio built-in MS test, and everyone started having those discussions about what is a unit test. Okay, don't call out of memory, that's why they're fast. And then, like you mentioned, integration test. Oh, we're calling out to a database or a file system. And then there's been the conversation on full system acceptance tests, where your software actually has to be running on some type of environment, and then you call in from the UI or from the APIs. And so the industry has had those conversations, but new people coming into the industry without having gone through that are thinking, well, how should I do my tests? As you have a lot of experience in testing and you guys do it at Datadog. What type of segmentation do you use? You mentioned integration tests, but what types of test suites do you find that have sprouted up to say, you know what, this was good as an independent test suite, and this is when I run it? Can you give us a survey or a walkthrough of what types of test suites that you find common now that you have a lot of experience doing this?
Sure, yeah. So, I mean, ultimately, with all of your test suites, you're really trying to get is just confidence that the software works the way you think it works. So I think you need to, what exactly that means varies at depending on the view you're taking of it. So if you think about unit tests, as you say, like unit tests are typically a unit, and you can divide what a unit is. It could be a class, it could be bigger than that, it could be a combination of classes. But typically the best use for unit tests in my case is when you're doing tests where you give it an input and then you test what the output is. That often means that they're resistant to refactoring. So if you change internals or methods, then it doesn't matter, because as long as the inputs and outputs are the same, that's fine. And if those do change, then the test needs to change, that's fine. And it keeps things fast. So you're not, in those cases, typically relying on mocking a bunch of interfaces and setting up code. You don't really want to do that there. That's otherwise you're looking at the internals. So that's unit tests. If you go bigger than that, you've got some sort of test which tests multiple components, and it tests how they react together. So the integration test, if you're thinking about let's say a web app, integration test, I would typically think of testing just below the surface. I've heard them called like subcutaneous tests, where you're testing like just not ASP.NET Core, not anything like as part of that necessarily, but you're testing how a request is handled in terms of generating the required request that then gets sent down to the service layers, it gets sent to the database, and making sure what you get sent back at that point all works. Because then you've basically exercised almost your entire application. You just haven't worried about the HTTP bit at the front.
Mm-hmm.
And then you've got full system tests, which potentially, if you've got like a web application, say, that would be, yes, you've got something running, you can click a button, you can go all the way down. And sometimes UI tests where you want to make sure that things are actually visible on the UI. UI ones always seem fragile because, stuff moves around. You've got to handle, now there's a little bit more padding on this button, so you can't quite see the text you thought you were going to be able to see. And so all of that sort of thing feels like less payoff in a lot of the time from what I've seen. But those subcutaneous and potentially those full system, depending on the type of application you're building, they can give you really strong confidence that your application actually works. You know that you can still log in. You know that you can still create an order. Exercising of those critical pathways in your application before you deploy something new can just make sure that you haven't missed something small. Like when you're doing unit tests or even the subcutaneous tests, sometimes you can avoid. You can accidentally break things which you didn't realize when you put everything together. So I think those are generally what people consider the sort of standard set, I think. There's some other cases that we test at work where we can some smoke tests, basically just run something very simple. And that's what I consider those important parts. You run something simple, make sure it doesn't crash. Make sure you don't get anything, anything particularly alarming that would indicate there's fire. It's not necessarily testing everything's working, but it's making sure that the most important things are happening.
That's a really good point. I think anybody who's done software for just a few years has probably had some kind of situation where we deploy to an environment and we think we're good, but then the first screen or the first page it just blows up spectacularly and it's totally hosed. Like something happened where it is completely broken. And it could be just a deployment thing, could be in a packet. Who knows what it is, but it's broken. And you're right, just having some type of, you call them a smoke test, you like turn it on and see if it smokes. Yep. That was the old analog electronics kind of joke. It's like, well, let's just turn it on, see if it starts smoking. But just running something, because to do it manually, you pull up the first screen and click on a button. Well, that's what you would do manually. Well, why can't we have the computer do it? And get that answer a lot quicker.
Exactly, yeah. And there's a lot of tools for doing this these days. I mean, I think a lot of .NET developers use like Octopus Deploy. You can easily hook that into to Octopus or whatever you're using really for deployments. Because like you say, it's as simple as that. It's go to a web page and make sure the web page, for one, like doesn't just time out. and shows you
Yeah.
some bit of text which you expect to be there.
Right.
It can be as simple as that.
And so many applications now have startup logic. Like there's something that happens on the first request, first screen, even if it's a Maui app, they're on first load, it's got to do something. And we could test every individual function with integration tests, subcutaneous tests, but that startup logic only actually runs when you start up the full application.
Exactly. And then when you add in like data and database migrations and everything like that into these deployments, yeah, that's where it gets fun.
Yeah. Awesome. Well, I feel like we could talk about testing frameworks for quite a while. There's no way we could dig into anything. But for those younger developers there, is there anything in the realm of automated testing that you kind of wish somebody had told you when you were getting started as a programmer? Maybe we could save them some time.
I think one thing I have particularly grown to enjoy is just like making sure you're thinking about testing when you're writing your code. Like writing code that can be easily tested, I think is really important. Like it's not necessary to make sure that you can test every method in your application. Some things are private, they should be private, that's fine. But writing things which are public in such a way that you can test them easily is something which I think takes a little while to get your head around what that means. And you only get that by trying to test your stuff. You write some code, you try to test it, you're like, oh, this is really hard to test. I think that's it's a skill that I think you have to learn. Like there's sort of small things like being able to pass in dependencies explicitly, not accessing global state and things like that. But the only way to really learn it is just to feel the pain and try it. So write some tests and see how it goes. Awesome.
Well, Andrew, thanks for coming back on the podcast and talking shop with me about testing frameworks. I appreciate it.
No, it's a pleasure. It's been good. Thank you.
Oh, fantastic. And until next time, dear listener, keep shipping.
You've been listening to the Azure and DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and anywhere you get your podcasts. Visit our sponsor, ClearMeasure, at www.clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.